In this video you will learn how to exploit file inclusion vulnerabilities. So local file inclusion, remote inclusion and directory traversal. This is vulnerabilities that often happen with websites, and it is quite easy to exploit those. So in some cases the websites are written in a way that could give you access to the system, and not just the files that the programmer wants you to open, but also you can open files on the file system. So for example, you might have a website URL as shown on the screen, like this one, and the parameter string, so in this case file, that one tells the file you can open. So for example, in this case it opens the file.cv or a user resume PDF file. Okay, that works as intended, but it might be that they didn't do any input validation. So in that scenario, you will be able to open files on the file system. I'll show you how that works a bit later. So the URL is comprised of several parts. First, we have the protocol. So first there is the protocol, which is the first part of the URL, so that's usually HTTP or HTTPS. Then of course there is the domain name. So the second part is the domain name. Then what you have is the file name. So that's not the file that you want to open, but actual web page. So I'm gonna color it. So that's the file name. And finally you have the file query. So in this case the query is file, and of course it can be different, but this is generally how such a URL is built up, right? So you have a protocol, domain name, file name and a query. And you would be able to, when you click around the page, the file name might actually change, right? The parameters. So in this case, there's only one parameter. There can be multiple parameters. In this case, there's only one, but for this example, it's okay. And on the web, you might find the same if the website was badly programmed. So when you open this URL in your browser, not this one, but any URL, it will do a GET request and then return you the file. So you would be able to get the file. I mean, that's what the programmer wanted to do with this kind of URL. So let's see what is actually happening. So first the user or the visitor will send a request to the computer, to the server or the website. The website is running on a computer called a server, and it will do the request to the file get.php. Then it will use the file parameter to specify which file. So the file specified will be in /files/cv PDF. Now, because the system automatically assumes a default directory for a web server, it is actually in var www/html/files. So every website is running in some directory on the file system, which usually are www/html. Just like if you were running a Windows server, it wouldn't be in c/, it would be in some directory. So usually that directory is for www/html. And then the file parameter will be used to indicate the file location, so a relative /file/the file name, and then return the file. So that is the general flow. So with a vulnerability, what is happening is that instead of specifying this file, you make it go up or out of that default mode, out of the default flow, and indicate another file. So this exploit or this vulnerability can exist in many programming languages, for example in PHP, but you can also, programmers also make this mistake in other languages. So you can hack that by changing the file name, changing the input. So whether a website is vulnerable to this file inclusion vulnerability really depends on the programmer, because of course they can defend against this kind of attack. But the main idea is that you are able to read sensitive data, for example, a password file or other files, and maybe even take over the server, have remote command execution. So it really depends. If some sensitive data is exposed, then that could also happen, that you can hack into the server. So the general idea is that as a file parameter, you might specify something else and gain access into the computer or read sensitive files. So let's see that in practice. We have a web URL here with file/readme.txt, which then opens this readme file. Now, there's also some other file/apps.txt. So, nice little program, right? And this website program shows you the file contents that you specify. So the programmer might think that it works as intended, they want to go home, it's 5 p.m. or they don't just really care. So what can happen is that it might be vulnerable to directory traversal or path traversal. So with that vulnerability, you can read the operating system resources such as files on the server, and to exploit this vulnerability, you manipulate the web URL. So this actual URL, you change it such that you have access to the files. So it is actually quite easy to do this by changing the input. And why it happens is that, for example, the programmer might have used file get contents in PHP, in other programming languages another function, and the file get contents function, so if we look that up, so this function, what it does is it reads an entire file into a string, which is text, and then it shows that. So if they use this function and they didn't filter the input, the file name, what we can actually do is open any file on the file system. Now, we know that this system is running PHP, but of course we would want to know what is the operating system running. Is it a Windows server? Is it a Linux server? So you can go to the developer tools, more tools, extend web developer tools. Every browser like Chrome and Firefox have these developer tools. We click on network, we click refresh, click on the request, and in the response it will tell you the server. So in this case it tells us Ubuntu Apache. So Ubuntu is a Linux server. So now we know it's a Linux server, and this is particularly useful because every Linux system and every Windows system organizes files in the same directories. So if I show you the Linux directories, just gonna open that. So Linux directories are always like this, and this picture might actually be more clear. Enlarge that. So Linux directories are always organized in the same way. So you have the slash, which is the top of the file system. Then you have different directories like home for the user files, etc for the config files. You have bin and user, which contain programs. And in the var you have some log files. So what you can do, if you know this structure, if you know it's Linux, then of course you might be interested in opening config files, so in etc, or perhaps var log files, or perhaps even user files on the system. So the way to do that is just to test out first if the web page is vulnerable. So in this case we have a website here, and what we can try to do is to move up to the slash directory. So in this case in the slash directory, so we try to move up using .. and we do that many times to go up to the slash directory. So we remove this and type .. so that moves up to the directory. And then you might want to open, for example, the file etc issue. So let's try that again. And you'll see we opened the file etc issue on the system. Now of course we can try to open anything, so etc issue is just a file telling the system. We might try to open the password file, so that's passwd. And there we go. We now opened the we can close this actually. We open the passwd file, and then you can find out the users on the system, or we just found out. So for example, we have the user Ubuntu here. Anything higher than or around 1000 is a user on the system. So this system has one user, Ubuntu. You might be able to also open other files, so any file in etc. Perhaps you can open etc shadow, and you see we're not able to open this one because we get a permission denied, so the user cannot open that one. But it really depends on how the system is configured, so you might be able to open that one or other sensitive files. And not just in the etc directory, right? You might be able to open files in the var directory. So in the var, say, let's just look it up for Ubuntu. See if we can see the default log files. So okay, maybe we're interested in the authorization log, so var slog out log. And okay, that's Google messing around. So of course it's var log out log. You see we were not able to open that log file. You could try some others like syslog or application logs. Maybe in the etc is more interesting, the config files. So etc files. Might be you're interested in the host file or environment file. We can open sources.list. So one thing you could do is just to have a Linux Ubuntu system at hand and then just compare the files so that you can easily look in the files. So we could try to open etc/sources list. You see that file doesn't exist. The app sources.list. You see we can open the sources file, and so you might be able to open different files using this vulnerability. So just in the file parameter, going up a directory // repeat that several times until you're in the in the root, so in the top directory, and then you can try to open any of the files on the file system. Usually what you might be most interested in is of course the etc directory, and you can find out users on the system. Once you know the users on the system, for example, we know that when we open the password file, that there is a user Ubuntu. So in here there's a user Ubuntu here. So obviously the next thing we could try is finding files in the home Ubuntu directory. Now, if the server is not running a Windows server, of course, the files are not in the etc directory, so you will not find this directory structure. Then you might be more interested in other files like boot.ini or windows/win.ini. Like the same kind of thing works, but of course, Windows systems organize their file system different. So then you would say, for example, open boot.ini. Or windows/win.ini. Of course, that's in the case of a Windows server. Now, this is a Linux server, so of course you might be more interested in password, showing the users on the system, etc issue that you saw before, that shows the current system. You might be interested in etc profile. So the profile file controls some export variables. You can try to open /proc/version. That shows you the kernel version. Kernel is the core system. So you can say proc that version. So now we know the kernel version, so you could check is that vulnerable or not. You can try to open etc shadow, which contains all the passwords. So in this server we had bad luck because we couldn't open the etc shadow file. We had a permission denied error. But if that's not the case, you can then crack the passwords and have access into the server. You might try to read emails for the system. So that's in var mail root. This server doesn't have mail installed. You might system log, so var log, for example, dmessage. So you see, it didn't exist either. Another thing that it can be really useful is private SSH keys. So if we know, for example, home Ubuntu, and SSH keys allow you to log into a web server. So and those are always stored in .ssh. So you can try .ssh, and for example, if they might have ID RSA or other keys stored in their home directory. Now another thing you can try is to read their history. So that's in home Ubuntu, well, depending on which user you found, or /root, the bash_history. So you can try to now read any file on the file system that might give you more information on accessing the file system, or passwords, or perhaps SSH keys that allow you to log in directly. So it's a very serious vulnerability, because by reading files on the file system, you can gain access into the server. So a local file inclusion, or LFI attack, is always for websites, and it's always because developers or programmers lack the security awareness. With the PHP programming language, so you'll see that for this example, the file ends in .php, the URL ends in .php, so you can see it in the file itself. You'll see if it ends in .php, you know it's written in the PHP programming language. Now it might be another programming language like ASP, JSP, or Node.js. But in all of these programming languages the same. If they don't check their inputs, then they might be vulnerable to an LFI attack that we just did in the previous lecture. Now in PHP there's many functions, like there's file get contents, which can open a file. So the function file get contents, they might use the include function, so include with whatever. They might use require with some file. So all of them more or less do the same. You'll see file get contents, they read a file into a string. Include will also do something like that. And there's also require, which will load the file as well. So it doesn't really matter what the programmer used. If they don't validate their input, if they don't check the inputs, then the attacker might open any file on the system with // going up to the root directory and opening whatever they want. And this is not just specific to PHP, so it can happen in ASP, in JSP, or Node.js apps. This local file inclusion attack can be done if they don't check their inputs. So in all of these languages it works the same. So you just change the parameter with // move up to the directory and try to open what you want. For example, the etc password file or the etc shadow file. It's important that you know which operating system is running. So if it's running Linux, of course you have an etc password file, but if it's Windows, then the etc directory doesn't even exist, and you might be interested in Windows files that can provide you more information about the target system. So as you see here, we use the get.php. There's also another program for this example called ink.php, and both of them work the same. So in this case, we didn't do path traversal, but really did local file inclusion. So instead of the program using file get contents, it was using include for including a file. You see, with include you can include files in PHP, so it doesn't really matter. So with the file get contents, the attack is called path traversal. With include function, it is called local file inclusion, but the principle is the same, right? So you can change the path and open any file on the system you want. So this is the actual PHP code. You'll see it's just one line. If you didn't program PHP before, don't worry, but you'll see a get file, so that gets the file parameter, and include then loads the file and shows the file. Now obviously this is vulnerable because the file parameter can be anything you want. Now I could enlarge this font a bit to make it more readable. So the file parameter specify in the URL, so file is, and then whatever file. Now because they don't check what the file, the actual file, so it doesn't check if it's dot slash in the file parameter or anything, then we can open any file in the system. Now include loads that file. So this is called local file inclusion vulnerability. The other file was get.php. So this one is a bit more harder code, but what you'll see is they use file get contents with the file parameter, and then this makes it readable and it shows the data on the screen. So again, it's very similar, the attack. We can use dot slash, and it is because the file parameter isn't checked for wrong inputs. So in this case, obviously we shouldn't be able to use dot slash etc password, but it's vulnerable because that's exactly what we can do. It doesn't check for that input. So you can forget about the PHP code, but remember that we can open any file, or we can check a web application for this vulnerability by adding dot slash in the URL, in the parameter, and going up the directory. There's also the attack of remote file inclusion. So in that attack, instead of trying to access the computer's files, you try to include a file from your own computer, from your own server, and to execute that or to load that. So remote file inclusion is very similar. You also change the parameter. So instead of trying to open a local file like etc password or etc issue or whatever local file on the computer, you want to include a file on your own server. Now for this to work, of course, a permission needs to be set for the server. And for PHP, that's allow URL fopen, so that option needs to be on. For PHP, that is allow URL fopen, so that needs to be on inside a file called php.ini. So the programmer needs to make that mistake for this to work. And instead of loading a local file, you specify a file on your own server. So that could be whatever website you have. For example, let's say you own the site attacker.site, then you can open a file on your own, and the file, your own local file, would then be included. There's several things you could try to achieve with that. For example, trying to get sensitive information, to do cross-site scripting, so to run your own scripts on the victim's computer. Or other things as well. So the idea is that you then create the file on your own server. So in this case, it's cmd.txt. It could be, of course, also a script or anything else. And then when you open this URL, the target computer will open this file and run it. So that's what you would do. If there is no input validation and it allows all opening remote URLs, the web app will then fetch this file from your server and include it or run it. So it can be a PHP file, it might be a text file, or anything else, depending on what you want to achieve. So this attack is called remote file inclusion, and the only difference here is that you actually get the file from your remote server, from your own server, in order to hack the server or whatever you want to do. So if you have your own website, what can you do to prevent this kind of attacks, like local file inclusion, path inclusion, remote file inclusion? So the obvious is that you need to check your inputs. So in this case, the input is a remote file. It might be a local file. So you always you have parameters. So in this case, we have one parameter, query file. Then what you want to do is to always check that input. So does it contain .. does it contain double slashes, and so on. And of course, you also want to update your software, turn off PHP errors or whichever programming language, because, for example, here we try to open etc shadow and we get very useful information as an attacker, like, oh, permission denied. So we might try to open a different file, or it gives the attacker useful information. Now you can set up a firewall to mitigate this kind of attacks. PHP, you can also disable file inclusion stuff. So, or let me try to open it. So in PHP, there's a file called php.ini. There's always a file called php.ini, and in that file there is parameters you can configure or permissions. And what you want to do then is look for allow URL fopen, and that should be disabled if your app doesn't need any file inclusion stuff, and also allow URL include, so disable both to prevent those kind of attacks. Now, this would enable file uploading altogether and file viewing. So you might want to do input validation instead. So verifying the actual input, right? So never trust the user input. Make sure you have valid validation against it. And you might also try a blacklist and a whitelist. So anything in the whitelist is allowed and anything that's outside is not allowed. So that's something you can try as well. So there's different mitigations you can do against this attack if you're a developer. So now let's hack into the server. So one thing hackers will always do is follow a process, and one of the first things is enumeration and scanner. So that's one of the first steps. Let me enlarge this font here. This default font works really well for when you're using the system, but when you're making a course, those font is way too small. So one thing they could do is do a scanning on the system, like with nmap, see which applications are running on the server. So nmap, in this case webapp.hqr, tells us that two servers are open, a web servers and an SSH service. Now, SSH allows you to remotely log into a computer and do administration, install software, and basically do anything. So that's always interesting to have SSH. Now, I have a course on SSH if you want to learn a lot about SSH, but basically it gives you terminal access into the server, into the computer, and allows you to run commands. Now, it might be that it is password protected, so you need an actual password to log in. The other thing is HTTP. Now, that's a web server. Any website that you open starts with HTTP or HTTPS. That is the protocol, so in this case a web server. So we have a URL here, include.php !files, and we can try local file inclusion. So we move up to the directory etc password, and then if we scroll down, we see username. Any user starts with 999 or 1000 and higher. So all the other things you see here, those user IDs, those are system users that we cannot use to log in. But anything higher than 1000 or 999 can be used to log in. So now we know the user, which is Ubuntu. So we know that SSH is open, so we can try to log in. SSH Ubuntu at, let me minimize this, at the target website, which was webapp.hqr. Can type yes. And now what we'll see is a password screen. So we know the username, and we might want to do brute force password attacks, which is just going through a list of commonly used passwords and try to gain access. On Kali Linux, there is a list like that included by default. For example, in the directory user share word lists. We have the rockq txt gz, so I'm gonna copy that to the home directory, paste it, and now extract it. And we'll use a tool that is, let me refresh this. So a password list, 40 million passwords. There's other lists as well. You can try to just brute force it, so try every password one by one automatically in that list, using a tool called Hydra. So Hydra -L, we know the username. It's Ubuntu. We found that in the using the local file inclusion vulnerability. So Ubuntu. Type .. and so on, etc password to find it. Now the password, we can try the password list. So rockq txt, and of course we want to attack SSH to give us access into the system. And that's all. We press enter, and now we wait. It will try all those passwords automatically. If it's a weak password, if it's a commonly used password, it will find it. So in this case, it found the password. So we can now use SSH to log into the computer. So let me open a new terminal, and we're gonna log in. So SSH Ubuntu at webapp.hqr, and it found the password of the system. And you see now we're inside the server. So inside the Ubuntu system, we can browse around. Example to var www HTML, and you'll see we have the files here, index.php and all the other code. We are inside the server, so we might try to go in home Ubuntu and see files in that directory. And of course, the next step is privilege escalation. So hacking always is in several steps. We are a regular user now. We are not an actual root user. Root is the system administrator. So we have access into the computer, but just as a regular user. So the next step hackers will do is to try to become administrator in the system. Because of course administration can do any administrator. You might know it from Windows computers, or root for Linux computers, which is the same, and can do anything with the system, can install new software, can install backdoors, and so on. And another thing the hacker will try to do is to make sure that he keeps access. So now has access into the system, but of course wants to keep access into the system as well. Now there's different ways that the hacker could keep access into the system. One way is just to add some scripts to the computer, for example to run commands. So in var www HTML, could, for example, open a reverse shell. So you don't have to program that. There's lots of codes like that online. So type reverse shell PHP, because we know this server runs PHP. And you can find some. So you'll find C code here. So I might just copy that. And add it. So reverse.php. And you'll see in this case, it's not writable. So we first need to become root. There's different ways to do privilege escalation. It might be that some programs can be executed as root. So if we type sudo -l, it might show us that some commands can be run as root. Now in this case, it says no password all. So all we have to type is sudo to become root, or sudo bin bash. And you see now we are root. So in this case, it's very vulnerable. We are immediately administrator. But it might be that only some programs are executable as root, which is more likely. Then you can use GTFO bins. Inside GTFO bins, there's all kind of tricks. So if we type sudo, all kind of tricks for different programs to become root. So you can see all kind of programs that if they are set up with the wrong permissions, they let you become root. For example, VI. You'll see we can type these commands to become root. So let's say the root actually has a password, but the VI is configured wrong. So you would type sudo VI and then those commands. So set shell is bin/sh and then type shell, type who am I, and you'll see I'm root. So if it shows that you cannot run everything as root but some programs, then you could use that. There's also other things you can try to gain access to root. I have a course on that called Privilege Escalation. It's all about how to become root in the system. Okay, so the next thing, of course, the hacker will want to do is to make sure he keeps access, because maybe they find out they are hacked and they want to solve that. So what you can do is to add, for example, to another PHP file, let's say reverse PHP or PHP, whatever you want to call it. And let's say with PHP, you can run commands easily using the exec. So if we search for PHP exec, or shell exec, that executes an external program. So we can say exec with any parameter or command. So in this way, we keep access into the system. We created hack.php. And we can say just open the URL. Hack.php command is, for example, ls. Now we don't see any outputs, so we need to store the outputs. And then output the output. So this little program, it will just run the command you specify in the parameter and show the output. So you'll see, okay, that shows us not the output, but we want the return value, sorry. So we copy the whole stuff. So let's try again. Instead of echo, try print R. And it shows you the output, right? Sorry, that should be redfall. Okay, that doesn't really look like the output. So instead of the exec function, you'll want to use the shell exec function. So sorry about that. I'm gonna remove this. And the output is then returned. So this stores into the output. So shell exec will run the command, and the output of the command is then stored in the variable output. So let me remove the other stuff here. And we can then return the output. Remove this. So just 2 lines of code that will always allow the hacker to then access the system. Now, given of course that you can run PHP on the server. So now we can run commands, so ls, or for example date, or maybe we want to output the password. So now we can run commands as the user. We can always run commands using this little script with 2 lines of code. So now we always have access. Another thing they might do is to add users to the system themselves. I mean, if they can access the server, why not add new users to the system with new passwords? So they might try add user, whatever user they want. They might add new users to the system if they have access to the system anyway. They might add SSH keys to log in remotely. There's different ways to make sure that they keep access into the system. So one way is through programming. Of course, easier would be to add new users to the system. Maybe some other tricks as well, just to make sure they stay access into the system. They keep access. So this is just one way. So what we did to attack was use the local file inclusion to find the username. So we found the username using the local file inclusion vulnerability. In this case, we found the Ubuntu user. And then what we did was use Hydra to gain access into the system with a password list and try to brute force the password. So this is just one way that you might gain access into the server depending on the server.